Okay, so today we're going to be talking about Cramer's rule. You've already seen this. This shouldn't be nothing new. And so first of all, a little history. Cramer's rule was actually named after a mathematician named Gabriel Cramer. He lived from 1704 to 1752, so not very old, okay? A little bit about him, because this is kind of what's interesting. When he was 18 years old, he was awarded a doctorate. And some of you are 18 years old right now. And so when you think about that, he actually took and got his doctoral degree, which was a pretty big deal. Okay, at age 20, they made him the co-chair of math at the Académie de Clavien in Geneva. That's Geneva, Switzerland. Okay, and then at age 30, they actually made him the chair of the math department. Okay, so when he was only 20 years old, he was actually a co-chair of a math department, which is pretty impressive. So this guy kind of knows what he's talking about. And so if you look here, how we find Cramer's rule, or how we use Cramer's rule, is we use determinants. And we've looked at determinants, and we use determinants to solve a system of equations. And so first of all, I know that x equals the determinant with respect to x divided by the determinant. And you're probably wondering, what is this d, dx, dy, and dz? Well, we'll look at that in our first example. Okay? Now, if I only have two equations, which that's a distinct possibility, I am only going to use these two. If I have three equations, I will use all three. So we're going to look at a system of two equations, and then a system of three equations, and then you will have the rest of the time to work. So let's go ahead and look at the next slide. It says solve by using Cramer's rule. Now we looked at using an inverse matrix yesterday. Remember that when we did A inverse times B? Okay, you can also use elimination. You can also use substitution. You can also graph those two lines to get a solution. And now we're going to look at how you can use Cramer's rule to solve this. Okay. So what I need to do is I need to find what D is. And then I need to find dx, and I need to find dy. So what D will be is D is going to be all the coefficients on the left side of the equation. So in this case, 4, negative 2, 3, negative 5. Okay, so that's what D is. Dx. To find dx, what I'm going to do is it's also going to be a 2 by 2. I need to use 10 and 11. And what I'm going to do is I'm going to replace the x column here with 10 and 11. So my dx will be 10 and 11 vertically, and then my y column stays the exact same. What do you guess you're going to do with the dy or the dy? Yep. Leave the x's alone. So 4 and 3. And then I'm going to move the 10 and 11 for the y's. Now, you could do these on your graphing calculator and type these in and find the determinant. But I actually think it's a lot faster to just do these by hand. Okay, by the time you spend typing these in, you probably could already have this calculated. Because if you remember, in order to find the determinant, I take this times this, which will be what? Negative 20 minus this times this, which is negative 6. So what is negative 20 minus negative 6? Negative 14. All right, let's look at dx. Negative 50 minus negative 22, which is 28. Good. And then, last but not least, I get 44 minus 30, which is 14. So see, it was almost faster for us to do those by hand in a 2 by 2. Okay, so now in order to find my solution, what I'm going to do is I'm going to take dx divided by d, That's my first answer. That's my x-coordinate. And then my y-coordinate will be dy over d. And so if you notice, they all come out nice and neat. What is my ordered pair going to be? Two, negative 1. Yep, there you go. So that's how you solve a 2 by 2 using Cramer's rule. Probably not the most efficient way to solve a system of 2 equations. Now when we get to the system of 3 equations, though, Cramer's rule actually is probably the most efficient. Okay? If you remember when we did these in Algebra 2, you had to eliminate one variable. You combined like the top 2 equations, you eliminated one variable, and then you eliminated one variable in the bottom 2. And if you remember, this one took up like half a sheet of paper.
Oh, no.
Okay, with Cramer's rule, it won't do that, especially since we're going to be using our graphing calculators. Okay. And so, D. What is D going to look like?
4, negative 1, 1.
4, negative 1, 1. Yep. And then?
2, 2, 3.
Okay.
5, negative 2, 6.
5, negative 2, 6. Okay, let's go through and we'll write out all of them and then we'll go through and find the determinants. So dx is going to be negative 5. I'll go negative 5, 10, 1 first of all. And then what will my next column look like? Negative 1, 2, negative 2, and then 1, 3, 6. So the other 2 columns stay the exact same as they were in the purple. Now dy, once again, if you just want to look at the purple, okay, so the purple going down is 4, 2, 5. Oh, I'm in the y column, so in place of the y column, now is when I'm going to put negative 5, 10, 1. And then the z column is still going to be the same as it was in the purple. And then last but not least, dz. Once again, if you look at the purple, the first 2 columns will be identical. And then the last column will be negative 5, 10, 1. So now what we're going to do is we're going to use our graphing calculator to calculate the determinants so we don't have to do this manually. So remember to put your matrix in. I'm going to go to matrix. Okay. And I'm going to go to what? Edit. Okay, so let's go ahead and edit matrix A. And we'll go ahead and put that in matrix A. Okay, when you get it entered in matrix A, I want you to quit. And then we'll go through the steps as to how you find the determinant again. Okay. So do we remember how we find the determinant? What do I do? Matrix, math, and then which one is it? The first one, and then I have to go back into the matrix again, and then A. Okay. Yep, just do the first one. What do you get?
55.
55. Okay, now what I want you to do is I want you to just change matrix A. Okay, change matrix A, and then I'm going to show you how you don't have to do that determinant every time. So negative 5. So basically, all you're going to have to change is the first column on this one. When you quit, I'm going to show you now, once everybody gets that entered in, what we can do instead of having to type in determinant of A again, I can actually recall that previous line. And so if I hit the blue second button and the enter, it actually recalled determinant of A, so you can press enter again, and then that way you don't have to go through all those keystrokes. What did you get the determinant of X to be? Negative 55. Okay, so let's go in and let's find the determinant of Y. I I would just use A for all of them because then you can just recall it every time. You don't have to worry about typing a determinant of whatever it is. What'd you get? 165. Good job. What'd you get for the last one? 110. Okay. So now, in order to find my ordered pair, I'm going to take dx divided by d. I'm going to take dy divided by d. And then I'm going to take dz divided by, oops, that's supposed to be a 10, divided by d. Now you're not going to have to write out what I have in yellow. You probably could jump to the answer. I'm just doing that for anybody that maybe isn't here today and they're watching so they understand where we come up with the numbers. And this should be your order triple. Questions? Now once again, you can calculate these 3x3 determinants manually. Okay. Or you can use your graphing calculator. So this is what I need you to do. Page 392, 5 through 8, 11 through 18. Okay, page 392, 5 through 8, 11 through 18.